Okie doke. So now we're on to 4.1 part 2. Today we're going to talk about how can I use degree measure. So all the things that you already know about degrees, how we measure, one of the ways we measure an angle, and then how does that relate to what we talked about from part 1, which is radians. So we have different ways of measuring the rotation that an angle makes, degrees and radians. So we're going to talk about how we can kind of translate between those two. So let's get right into degree measure here. There's a lot of these things you already know. One complete full rotation counterclockwise around a circle corresponds to, if you go all the way around a circle, how many degrees is that? 360. All right, so I'm going to use the degree symbol. I know they said degrees, but just to be clear, anytime you see the degree symbol, you can assume it's in degrees. All right, so what's halfway around? Like when somebody changes their mind, they do a 180 degrees, like they're going in the opposite direction. That's where that saying comes from. If you do a 180, that's what they mean. So halfway and all the way around in radians, remember, see this is a good from part 1. All the way around the circle in radians, you remember? It was like 6 of those radius measurements. So if we do 6 of them, we get around, and that was 2 pi. If we go halfway around, remember that was 1, 2, 3, or pi radians. So in radian measure, it's pi or 2 pi. So those are what we're going to be using today as well to go back and forth. All right, so how would you graph or draw the picture of 50 degrees in what we call standard position? Some good review from yesterday. So standard position. So we're going to make a quick sketch of this. Standard position means your initial ray is along the positive x-axis, and you have your vertex at the origin. Since it's positive 50, that means we're going counterclockwise. And we'll make that a little bit more than halfway. There's 50 degrees. That would be a 50 degree measurement in standard position. So let's talk about what we know about these. Coterminal. Do you remember what coterminal means? Co, share, terminal side. So angles that end in the same position. So in radians, we added or subtracted a complete revolution. Well, we still do the same thing in degrees. So we add or subtract a complete revolution, 360 degrees. And remember, there are infinitely many of these because you can do that as many times as you want to. So how would you find angles that are coterminal with 50? Well, you would take 50 and you would add 360 to it. So 50 degrees plus 360 would be 410. That would be 1. You could add 360 again, and that would be 770, and you could keep going. Or you can do 50 degrees minus 360, which puts you at negative 310. So going in the other direction. Again, you could subtract 360 again, and get another angle value there as well. So you can do this as many times as you want. What this means is you're going to end in the same location. So how would you draw a 410? Well, still in standard position, you would go all the way around the circle once. That would be 360 and another 50. Well, sure enough, that's going to end in the same location. How would you draw a negative 310? Well, you'd start on your positive x-axis, and then you would measure negative to here would be 270. We need to go another 40, and yep, we end up at the same location. Coterminal, that's what that means. All right, let's talk about complements and supplementary angles. Complementary angles, remember, they sum to, remember, 90 degrees. In radian lingo, that would be pi over 2 then. Supplementary, that was complementary, I don't know what I said. Supplementary sum to 180. Remember, C comes before S, 90 comes before 180. So if you have an angle measurement to find its complement, you just do 90 minus the angle. So what would the complement of 50 degrees be? Well, that would be 40. What would the supplement, just abbreviating here, be 180 minus 50 degrees, so that would be 130. Remember, it is possible to not have these. If your angle measurement's too big, you wouldn't have a supplement or a complement depending on the size of your angle. So everything that we've already known about angle measurements still in play. We just have this idea of standard position and the fact that we know something about radians, which we'll be connecting in a second. One thing that we do have, though, that maybe you haven't talked about before is taking a degree measure and actually breaking it down into a smaller unit for more specificity, so more precision. So we can take this unit of a degree, and break it down into 2 smaller units. They're called minutes and seconds. So what this works very much like is when you think about reading the clock. If you think in your head, degrees are like hours. So if you think of it that way, I know it's not the same unit, but if you think of degrees like hours, the minutes and the seconds work exactly the same for the conversion. So it's a really helpful kind of just background in your head way to think about this. So think of degrees like hours, and that'll really help you. All right, so degrees, we know the symbol for degrees. It's just that open circle. Minutes, this is where it gets kind of also interesting. They use the 1 apostrophe, which is the exact same unit or notation we'd use for like feet. And then seconds, guess what? It's 2 of them. So like the double apostrophe quote there, that means seconds, which is just kind of like also what it is for inches. So we're using all of our different standard system here and kind of throwing things together. So symbol for degrees, minutes, and seconds. You'll see degrees, minutes, seconds like latitude, longitude. When you think about that, that's a degree, minute, seconds measurement. So it's 32 degrees, 58 minutes, 28 seconds. Also kind of like when you run like a marathon or something like that and they time you and they do hours, minutes, seconds, works very much the same way. So you'll see the same kind of thing. The conversions then everything are all the same. All right, so what are those conversions then? Well, if we talk about what it is for 1 degree, so there are 60 minutes in a degree. So I'm going to use my symbolism here. So 1 degree is equal to 60 minutes. If you want to put the word there as well, if that helps you. So it's very just much like a clock. In 1 hour, there's 60 minutes. In 1 degree, there's 60 minutes as well. Let's talk about minutes to seconds then. So in 1 minute, so I'm going to do my 1 minute, there would be how many seconds? How many seconds are there in a minute? Well, 60. So there's 60 seconds. And again, I'll say seconds here so you get comfortable with that lingo. What if we go all the way from degrees, 1 degree, to seconds? So basically what I'm asking you is how many seconds would there be in a full hour? So 60 seconds in a minute, 60 minutes in an hour, 60 times 60 would be 3,600. Sometimes that's handy to go all the way from seconds to a degree or an hour, if you want to think of it that way. We can use that conversion as well. So it's the same as what you convert when you convert time. And that's kind of a good way to think about that. So what we'll be doing is in real life situations, sometimes numbers will come to us in degrees, minutes, seconds. Our shortcut for knowing and kind of describing that is DMS. That's short for degrees, minutes, seconds. Sometimes it'll be degree as a decimal instead, so DD. Let me give you a real life example of that. So if you run, say I run a marathon, and my finishing time is, if it's a marathon, we'll do 15 hours, and we'll do 30 minutes and 30 seconds. So say that's my time. Instead of hours, minutes, seconds, oops, that was supposed to be 2, but it looks like one big one. What if I said I just did it in 15 points? Now 30 minutes is half an hour, so 5, that's half a minute. What if I just said I did it in 15.55 hours? That would be degree as a decimal kind of version, and this would be the degrees, minutes, seconds version. So if I have all 3 separate units or just all in that biggest unit, hours, that's the difference between DMS and DDD. So what we want to get comfortable with is how do we convert back and forth between something that's just straight decimal, so just in degrees, versus something that's split up in degrees, minutes, seconds. So again, like the difference of me saying it's 1 hour, 30 minutes, or just saying like 1.5 hours. So can I go back and forth? So we're going to try that. We're going to practice. Okay, so the first one, I want to show you what something looks like if that's written in degrees, minutes, seconds. So we have 14 degrees, 28 minutes, 30 seconds. So that's what that number, that's how you'd say it. They'd say change that to DD. What they want then is they want 14 point blank degrees. So they don't want it to be in minutes and seconds. They want you to convert over the 28 minutes and the 30 seconds to what part of a degree is that. So we need to use our conversion factors, right, that we talked about to be able to convert that over. All right, so let's talk about how would you change 28 minutes into degrees. Right, well, so it's the same as how would you change 28 minutes into hours. We do our hours in minutes, so 1 degree is equivalent to 60 minutes, so I'd be multiplying by my conversion factor. 1 degree over 60 minutes. Now, most people don't actually write it this way. Most people would just say, oh, I'll do 28 divided by 60, right? So think of it just like the clock. 28 minutes out of 60, what part of an hour is that? It's about half, right? It's a little bit less than that, and you just divide, but that's fine. This is how we do it. Notice the units of the minute divide out, and you're left with degrees, which is what we're going for. So we're going to do that calculation, and then we're going to have to add that to what the 30 seconds is. So I want to change 30 seconds also into just degrees. Well, what would we multiply by? We'll use our last conversion factor here, that 1 degree is equivalent to 3,600 seconds. So we're going to just, again, people often just say, well, I'm just going to divide by 3,600. Notice the seconds divide out. We'll do a little bit of our dimensional analysis here, and we can divide, we'll be left with just minutes. All right, so this is where we're definitely going to need our calculator. So we're going to do 28 divided by 60 plus 30 divided by 3,600. And what we're going to end up with is 0.475. All right, so 0.475 then, 475 is what part of a degree that would be. Now think about it just in terms of time. 28 minutes, 30 seconds is a little bit less than half of an hour, right? Which is a little bit less than 0.5, and yeah, 0.475. That's called degree as a decimal. So this would be our degree as a decimal answer. So it's only just in degrees. Let's go the other direction so we can practice going the other way. 64.545 degrees into degrees, minutes, seconds. So notice they want this. The one part that you have for sure right away always is the full degree part, so 64 degrees. But then they want you to fill in the blanks here. How many minutes is that? The 0.545, and how many seconds is it? So we need to convert over this decimal part, this part of a degree, to see how many minutes and seconds it would be. Now it's a little bit over a half, which means it's a little bit over half of a degree. So it should be a little bit over 30, right, when we think about that, because 30 is half, so it should be more than that. All right, so how do we convert 0.545 degrees into, we'll do minutes first. So how many minutes are there in a degree? 60. So I'm going to do 60 minutes per 1 degree. So do our dimensional analysis here. So we're going to start with that and see how many we have. So again, the degrees are going to cancel. We're going to be left with minutes. All right, so we're going to take 0.545 times 60. And that gives me 32.7. So that's 32.7 minutes. Okay, now let's think about if that's reasonable. So 0.54, again, a little bit over a half, which is a little bit over half of a degree. Since there's 60 minutes in there, a little bit over half should be 32. That makes sense. Okay, now here's the interesting thing, though. It wasn't a whole number of minutes, though. The whole number part was there were 32 full minutes, but we had this 0.7 of a minute left over. I've got to convert that now. That must be what I have left over in seconds. Now, if it had just been whole number 32, then I could have just gone ahead and filled in a 0 there for seconds, but it's not. There's a part of that left. So I have my 0.7 minutes. I want to figure out how many seconds is that. So it's not a full 60 seconds, but it's 70% of that, so it's going to be a fair amount. So we're going to do our conversion for how many seconds are there in a minute. So there's 60 seconds in 1 minute, and we're going to multiply. So it's just like what you do to convert over minutes into seconds in a clock. So we're taking our 0.7 times 60, and that's going to be 42 seconds. So that would be equal to 42 seconds. And again, notice the minutes would divide out, so we're leaving our units with seconds. So that's going to leave me with 42. Now this one ended up with a whole number of seconds. If you would have ended up with 42 point whatever, 7, follow your regular rounding rules. I would probably just round this to the nearest second. I would round it to 43. Or if it ended up to be like 42.1, I would have rounded it to 42. Now, if you get to the situation where, and this will come up, what if you end up with 59.9? Well, that would round up to 60. So like in terms of seconds, well, if it's 60 seconds, that's equivalent to 1 more minute, so I would add the minute on. So if this had ended up to be here, 59.9, oops, that's really hard to read, that would have been 60, then I would have made this a 33, so I would have added it onto the minute. So when you get to that whole, to that 60, you would add that on to the bigger category. Now, everything that we just did by hand, thankfully there is a shortcut for that on your graphing calculator, and we're going to talk about that so we can actually go back and see what that would look like, so we can change those back and forth. So let's talk about that and see how that works for you. So let's go to the graphing calculator here. I'm going to clear this. We're going to do the first one, which was the 14 degrees 28 minutes 30 seconds. So let's see if we can type those in. So 14. Now we need to go to our angle menu. So you need to find your angle menu. For me, it's second apps. So it's 14. And here you're going to see the degrees, the minutes, and some other things that are going to be really helpful to us. So I'm going to go ahead and grab the degree symbol there. And then 28, back to your angle menu, which is number 2, minutes. And then 30, this is the major bummer. If you look in the angle menu, the seconds are not there. It's actually above the plus sign. So you're going to do alpha and then plus, which is really kind of a hassle. But then the rest of it's pretty easy. Then you just press enter and look at that. It's already in degrees, minutes, seconds for you. So it's really, or degree is a decimal. So it's really easy to go from degrees, minutes, seconds to degree as a decimal. You just have to type the angle in. Now, if you wanted to change it back, you take that decimal and then we change degrees, minutes, seconds. And I'm going to show you how to do that with the second example that we did. So 64.545. Let's see if we can go the other way to DMS. So 64.545. Go back to your angle menu, and we just want, can you guess? Number 4. That means little arrow, change my answer to degrees, minutes, seconds. And there you go. This is a wonderful time saver. So I use this all the time. I wanted you to understand where it's coming from, how you do those conversions, but I would say most of the time people are just going to do that on their calculator. Okay, so let's talk about our 2 methods now. So we've talked about degree measure and we've talked about radian measure. What we want to be able to do is kind of seamlessly go back and forth from one to the other. So we want to be able to do that. So we want to think about what our conversion factors are here so we know what we're dealing with. So we know that 1 complete revolution in degrees was 360, and that was equivalent to 2 pi radians. We also know then that 180 degrees is equal to just pi radians. And that's the one that we actually use for our conversion factor, so that we know 180 degrees is equal to pi radians. So to go from one to the other, we're going to use that conversion factor. So that means we have to go from degrees to radians. That means you want radians in your answer. That means you want radians as the unit on top. You are going to multiply by the conversion factor then, pi radians over 180 degrees. Now, I would almost never write the radians, but I'm just trying to emphasize that that's what unit is in the numerator, so that's what we'd want. So that those are equivalent, just like saying 12 inches is 1 foot, and that's a conversion factor. So to go from radians to degrees then, you're going to multiply, same idea, but by 180 degrees over pi radians. And just kind of a cool thing to do, go ahead and divide that 180 divided by pi. So that 1 radian then, it's equal to, if you divide that out, 57.3 degrees. And if you remember in our picture that we drew yesterday, I said that first arc length, if you actually measure it on with a protractor, it's a little bit less than 60 degrees. So in your mind, just to kind of think about where that first arc is going to be, it's a little bit less than 60 degrees. It's a good estimate for what about a radian is. So if we're thinking about that conversion factor. So it's really easy for us to translate back and forth between this radian system and the degree system. Again, 2 different ways of measuring rotation. One measuring with degrees, the other measuring the arc length, which is the radian. All right, so let's do a couple conversions. That's going to be a big part of what we're going to be using throughout trigonometry here. It says convert 120 degrees to radians. Well, first of all, how do you know that you're in degrees? You see a degree symbol. So you want to change to your other way of measurement, which is radians. So we're going to multiply that angle by the conversion factor. So we're going into radians. So we're going to multiply by pi radians over 120 degrees. Notice that your degree symbols will divide out and you're going to be left with radian measure. And again, they almost never write the radians. You assume if you see nothing, it means radians. Okay, so how do we do that? Well, it's going to be 120 times pi over 180. Well, now you just have to reduce. If we want an exact answer, we're going to want it in terms of pi. That's what that means. So I'm just going to reduce this fraction. So 12 over 18, they each are divisible by 6. So when I reduce that down, looks like that would be 2 pi over 3, and that is in radians. Again, just for emphasis here, you wouldn't have to write it. But that's what we mean. 120 degrees then, think about that's in quadrant 2, is equal to 2 pi over 3 radians. We're going to talk lots more about what that means. So 2 pi over 3, that's like thinking of taking pi into thirds. So thirds, so remember pi is here. So if I'm doing thirds, 2 pi over 3, that's 1/3. That would be 2/3. So 2/3 of the way to pi. Well, that's exactly the same as 120 degrees, right? If you think about that location. So we're just saying that, yep, those are two different names for the same spot. So if I take 2 pi over 3, it's the same as 120 degrees. Let's go the other direction and see how that works. So this, it says change 9 pi over 8 into radians into degrees. Now, if it didn't say this word radians here, how would you know from that that it was a radian measure? Well, some people say, well, the pi kind of gives it away. Well, yeah, but it's not the most important part. The most important part is that there's no what? Degree symbol. So it's kind of one of those, ooh, okay, yeah, that makes sense. But if you don't see a degree symbol, it is in radians. So just be careful that you're thinking of it that way. So we're changing our answer into degrees. That means we want degrees on top. So technically, remember, this is radians. So we're going to multiply by 180 degrees then over pi radians. So the radians are going to divide out. That's the whole idea. And we're going to be left with whatever this disaster is. All right, now it's nice if it does have a pi in there. It doesn't have to. The pi's will also divide to 1. So what you have left then is 9 times 180 divided by 8. Now sometimes that ends up to be a really nice whole number answer. Sometimes it doesn't. It just depends on what the values are. And in this case, if you go ahead and multiply that out and divide, I think it's 202.5 degrees. So be able to get that degree measure. So we're in quadrant 3. Think about that from the picture standpoint again. Remember, pi over 8 would be taking pi, which is halfway around, and dividing it into 8 slices. So that means there would be 1, 2, 3, 4. And then we'd have another 4 over here. So there's your 8 slices. 1, 2, 3, 4, 5, 6, 7, 8. 9 pi over 8 then means I need to go one more slice. So I'm into quadrant 3. So does that seem reasonable for 202.5 degrees? Sure thing. So always think about the picture that goes with it for radians. It really does help understand those fractions. All right, let's do a few more conversions just to make sure we understand a couple of the little pieces here. If you have a negative angle, remember what that means. It just means you are going counter or going clockwise instead of counterclockwise. So negative 330, think about what that would be. You're going down, so that'd be negative 90, negative 180, negative 270, and then we're going to go another 60 degrees, so we'd be here. That's negative 330. If you're negative in degrees, you have to be negative in radians as well. You're still going around in that direction, so this is just the direction. So negative 330 is going to be a negative in radians as well. All right, so how do you change into radians? What would you multiply by? Well, we want the radian measure on top, so pi over 180 degrees. So those degree measures would cancel. And we'd be left with negative 330 times pi over 180. And then we're just going to reduce that fraction. If we want an exact answer in terms of pi, we just reduce. So 33 over 18 would be negative 11 pi over 6. Okay, now think about that. How many pi over 6s would you need to get all the way around the circle to make it 2 pi? So if I was going to make a 2 pi out of that, if I was going to do 6s, see if we can do this. So in pi, this would be negative pi though, it's going to be into 6 different chunks. So we'd have 1, 2, 3, 4, 5, 6. Now we need to go 11. So that means we're going to go 3 more here. So that would be 9, 10, 11. Yep, for sure. That would be the same as negative 11 pi over 6. If I went one more pi over 6, that would be 12 pi over 6. And think about that for a second. 12 pi over 6s, so 6, 6 on the bottom and then 6, 6 on the top, that would be the same as 2 pi or all the way around. So that location is the same. So if you think about like just reasonableness, or hey, are these two numbers actually in the right spot? It kind of does make sense. So whatever that denominator is, that's how many pieces you're dividing it into. Think in degrees, we feel super confident. We just want to get as confident in radian measure. So radian exact answer, we're thinking about those fractions. All right, let's do the other direction. So negative pi over 4. Again, if it's negative in radians, it's going to be negative in degrees. And notice, how do I know I'm changing it into degrees? What doesn't that have? Degree symbol. So I'm going to multiply by 180 degrees over pi radians. So again, the radian measure would cancel, the pi's would divide, and I'm going to be left with negative 180 divided by 4. And that does end up to be a nice whole number answer, negative 45 degrees. Let's think about the picture and see if that's reasonable. All right, so pi over 4, what that means is in pi, so halfway around the circle, and this would be negative pi, you're just going the other direction, that means you're taking pi and dividing it into 4 equal pieces, so quarters. If I'm going to do negative pi over 4, that means one of them, so that would be negative pi over 4. Well, yeah, that's going to be exactly the same as negative 45 degrees. There's 4 45s in 180. There are 4 pi over 4s in pi, so it's the same location. So what we're trying to get comfortable with is what spots are the same. Where do these end up? Okay, let's try this last one here, and then we're going to fill in some kind of commonly used numbers that we're going to see a lot. Convert 3 radians to degrees. So 3 radians into degrees. Now, it doesn't look the same as like the letter B. 3 doesn't seem to have any pi with it, but it doesn't have to, because arc length, oopsie daisy, arc length doesn't have to have a pi in it. It can be any measure. And if you think back to our picture from yesterday, so I'm going to go back to my radian picture here, kind of clear this off. 3 radians is the distance that goes to right here. That is an arc length. Now, it doesn't have to be in terms of pi. Halfway around is pi, 3.14. 3 radians is just a little bit less. So can you guesstimate what you think that would be in a degree measure? About how many degrees should that be? Almost 180, right? So a little bit less than that. We can still calculate it. So it doesn't have to be in terms of pi. It can literally just be a decimal number, an amount of these arcs, right, that we went around the circle. And that's why people like radians better, because instead of having to say numbers like 180, you can do things like 3, right? 3 something is going to be around that distance. So the numbers are smaller. They're easier to deal with. The conversion works the same, though. To change to degrees, we multiply by 180 degrees over pi radians. All right, so now remember, the radians symbol still divides out. We are actually going to have to divide by pi, though. So 3 times 180 divided by pi. Now, are you going to get a whole number answer for that? No, you're not, and that's okay. We just want to see what that would be. So can you go ahead and type that into your calculator, see what you get? So 171 point, let's go to tenths, 9, maybe? And that would be DD. That's degree as a decimal. Let's see what that would be as degrees, minutes, seconds. Can you write it that way as well? So I had used my pi key to find mine. So this is my degree as a decimal. You could round to whatever place you wanted. Do you remember how to change that to degree as a decimal or degrees, minutes, seconds? We go back to our angle menu, number 4. And so that would be 171 degrees, 53 minutes, and then to the nearest second, 14.4, so the 4 would keep it at 14 seconds. So it just depends on, that would be degrees, minutes, seconds then. What your application is, what makes sense, how specific do you have to be. So not every radian measure is going to be in terms of pi. They absolutely still exist. It's just how many arcs you're going around the circle. You may not get a whole number answer in terms of degrees, but that's totally fine. All right, so let's talk about some of the most common units of measure then in radian versus degrees. So we're going to talk about, we're going to be doing a lot of these relationships. So we're going to be, these are kind of what we call special values. They're going to become an integral part of your life for the next rest of your math career. So we're really going to try to get these nailed down. So let's talk about radians versus degrees. If it's 0 in degrees, that means you haven't moved at all. It's still 0 in radians. Let's talk about pi over 6. I have a picture of pi over 6 right here. So that's taking pi, which would be halfway around. So all the way to here, right? And dividing it into 6 pieces. So 1, 2, 3, 4, 5, 6. We want to describe what 1/6 would be in degrees. So do you remember how to change radians into degrees? We multiply by 180 over pi. And remember, the pi's are going to divide out. So we'd be doing 180 divided by 6. So if you divide 180 into 6 pieces, how much is in each piece? Well, that would be 30 degrees. So 30 degrees is equivalent to pi over 6. So that's an equivalency. It's something that's always true. So if you take 180 in 6 pieces, it's 30. If you take pi in 6 pieces, it's pi over 6. They mean the same thing. All right, let's do the pi over 4. So hopefully you can start kind of predicting what you think these are going to be. If this is pi, that means we divided it into 4 equal pieces. So 1, 2, 3, 4. We want to see what the equivalency would be for that. So pi over 4. Actually, the way they have it written, it's the 45. So I'll go that direction, I guess. So 45 degrees, that would be 4 equal chunks as well. Changing it into radians, you'd be multiplying by pi over 180. We'll follow the chart here. So 45 pi over 180. How do you reduce that? So for me, oops, I would be thinking, okay, how many 45s divide into 180? Well, 4 of them. So that reduces down to 1/4. So this would be pi over 4. So my equivalency then, 45 degrees, is the same as pi over 4. So in other words, if you take 180 in 4 pieces, there's going to be 45 in each piece. If you take pi in 4 pieces, there'd be 1/4 pi, or pi over 4. All right, let's take a look at pi over 3. That means taking this pi, remember halfway around the circle, dividing it into 3 pieces. So if I divide it into 3 pieces, what would each of those be worth in degrees? So pi over 3, see if you can kind of guess here, times 180 over pi. If you take 180 into 3 pieces, what do we have? 60 in each piece. Yep. So 60 degrees would be equivalent to pi over 3. Okay, 90 you probably already know. 90 degrees is the same as pi over 2. We can do the conversion. If you multiply 90 times pi over 180, we just have to reduce that fraction. 90 over 180 is half of it, so it'd be pi over 2. And hopefully the last two you know already, or at least one of them. Pi, halfway around, 180. Ooh, we haven't done this one. We know 2 pi is all the way around. So 360, I'll just add that one as 2 pi. How about the one in between there? 270. I don't have a picture of that, but let's see if we can draw that. So 270 would be starting here, and we'd be going down to here. So that would be 270. So what would that be in radians? So 270 degrees times pi over 180. So 270 pi over 180. Let's reduce. So divide out the hundreds. 27 over 18. Take a 9 out of each of those. Divide them each by 9. So that would give you 3 pi over 2s. If you think about that reasonableness-wise, if 90 degrees is 1 pi over 2, pi would be 2 pi over 2. Right? So 2 of those. Down here, it makes sense then that that would be 3 pi over 2. So when we think about these, what we call special values, we're going to be using these a lot. These are special angle measurements that we're going to be using throughout all of trigonometry. Okay, just make sure we know how to do a quick sketch then and where your angle is going to end up so you have some sort of a reasonableness for when you draw your pictures in degrees. All right, so we're going to talk about a few and what you would do with them. These are all going to be in standard position, by the way. Okay, so we're just going to practice a couple quick degree measures, and then we should be off to the races here. Oh, position, not positive. So standard position. Okay, so remember what that means. How would you graph 440? Now, if it's more than 360 degrees, that means you've done more than a complete revolution. So we're going to go all the way around the circle once. And how far would that be? When this is a positive angle, so I'm going counterclockwise. How much further would you have to go? Well, if I subtract 360, how much more does that give me? That gives me another 80 that I have to go. So that would be, keep going here, almost up to the top here. So that would be a positive 440. Notice a couple of things about how I drew my picture. I have my initial ray on the x-axis. I showed my direction arrow on the inside to show that I was going counterclockwise because it was positive, and I showed that complete revolution and the additional. So that's how you would draw that picture. So sometimes if the angle is more than one rotation, you're going to have to think of like that coterminal angle to figure out where it ends up. All right, let's try the next one. How would you graph negative 200? So I'm going to kind of erase these as I go. So negative is telling me which direction. Well, I'm going to be going clockwise. Think about your benchmarks, how far you're going. So if I'm going in this direction, that would be negative 90. This would be negative 180. And I have to go how much further? Well, how far is 200 from 180? It's 20 more. So I'd be going 20 more in that direction. So I would be in quadrant, oh, I forgot to say where this one was. Quadrant 1, right? Where's your terminal side? It ended up the same as 80. Okay, so where does this one end up? This ends up in quadrant 2. So knowing where that is. So this would be my action arrow. I would just do one of them with the arrow in that clockwise direction, and I would label it negative 200 degrees. So just be really aware that angle or that arrow on the inside is critical because that's going to tell me that it's a negative angle. And then make sure we think about, hey, where does that end up? Okay, let's try the next one. Now we're going to challenge ourselves here. 2 pi over 3. We've talked about this one. What some people will do is they'll go ahead and convert it into degrees. So multiply by 180 over pi so they can have a little bit easier time to think about what this is. So the pi's would divide out. 3 divides into 180 60 times. So 60 times 2 ends up with 120. Okay, so what quadrant is 120 in? Positive angle. That would end up in quadrant 2. So we'd end up in quadrant 2. So being able to sketch it. Now, some people don't even do that, though. They just think, okay, this is pi over 3. That means if I take pi and divide it into thirds, so I'm dividing into thirds. So 1, 2, 3, that's kind of a terrible picture. Then 2 pi over 3 would be 1, 2 of those, and that would be my terminal side. So some people actually can just look at it and start thinking in radians, and they don't have to actually convert it to degrees first. So if that's easier for you, that's kind of where we want to get to. So if we can think about that, but you can also convert it to degrees if that's easier. All right, so negative 5 pi over 4, let's try this one. We're going to do it both ways. We'll think about degrees, and then we'll also think about it in terms of radians. So if you multiply by 180 over pi, so we are going to get rid of those. 4 divides into 180. 180 divided by 4, 45, and then we have 5 of them. And remember, if it's negative in degrees, it's still, or in radians, it's still negative in degrees. 45 times 5, go ahead and multiply that out. That'd be negative 225. Okay, so where would that put you? Negative 225. So negative 180, clockwise again, and another 45 degrees. So we would once again be in quadrant 2, so being able to locate that. How would you do it just in radians, though? So let's think about negative 5 pi over 4. So pi over 4 would be taking pi and dividing it into 4 pieces, equal pieces. So 1, 2, 3, 4. And then I need to go negative 5 of them. So I need one more piece. And sure enough, same exact location. So if you can start thinking in radians, super helpful. So we have this idea of radians and degrees going back and forth, really important concepts in trigonometry.